Can you guys hear me? All right, good. We're going to go ahead and start. I actually have a lot of slides and a lot of things to cover, so I'm going to actually use up all 60 minutes we have. So first of all, thank you. Thank you very much for coming. I know today is the last day of the conference. It's kind of tough to be in a session. I'm sure you guys went to a lot of sessions and learned a lot. So thank you very much for being here. My name is Thomas Park. I'm a solutions architect from Washington, D.C., Herndon, Virginia. So before we start, I know we have a lot of people in the room. I just kind of want to see how many people and what type of people are in the room. So if you can, please raise your hand if you are considered experienced DBA. Okay? Any storage engineers in the room? Okay, good. What about architects? Enterprise architect, solution architect? Awesome, awesome. Any operations network? Okay, good. So this is great because I was actually expecting a lot of different types of people to come, and just because the data itself is such a wide topic that covers a lot of areas. So let's get started. So I want to start with a story. My family, I have 4 kids, and every spring break, we like to take a trip during spring break and learn more about famous American people. And this year, just past March, we went to Charlottesville, and we decided to learn more about Thomas Jefferson. So as we were going around his house, we saw this strange device in his library. Apparently, Thomas Jefferson used this device to copy every single letter that he was writing. And before he sent it out, he wanted to keep a copy of it. And he wanted to keep a copy of it because he wanted to preserve data. Obviously, if he sent it out, it would never get it, right? So he kept every single letter that he sent out to his colleague. He also wanted to improve productivity, right, performance. Nobody want to write the same letter twice. I mean, who does, right? So by using this device, he only had to write once, and he had an exact same copy of the letter. So I think, although he used this device about 200 years ago, the way we actually communicate and the way we use technology to communicate has changed, but the purpose of data replication really hasn't changed. We use emails, we use social media, but we still would like to save, I know many of you save your sandbox, right, for archiving purposes. So really, today's talk is about what type of replication design options we have in AWS, but be able to still meet some of the business drivers or the main goals of data replications. So today's agenda is about data replication design options in AWS. We're going to take a look at a very few options that you have. And we're also going to take a look at design factors and challenges associated with it. And then we're going to introduce several use cases. These are common use cases that when I talk to different customers, especially enterprise customers, they would like to know how can I achieve this type of scenario. So we're going to introduce several scenarios. And some of the options are actually you can do it yourself, or you can leverage managed or built-in AWS options. And in between, we're going to try to squeeze in several demos. So you probably know that through some of the sessions that we had, we have many, many different types of capabilities, all the way from global infrastructure that we have in different regions around the world. We have networking capabilities that allow you to replicate data. We have different types of replications that you can do in compute database, as well as storage. But a lot of times what we do is we kind of pick or choose one particular service, and we drill down into how to use that replication. And a lot of times we learn about that particular capabilities and look for, it's almost like you found a hammer and look for a nail, right? What I like to do is look at it from a much broader sense. I want to take this time to step back. And just because the word data is such a broader term that carries many different meanings and perspective, I think it's important to step back and see what type of capabilities are there from a data replication perspective. So another aspect of that is there are a number of capabilities that our partners build, the value-added capabilities, because AWS itself offers very low-level APIs and capabilities that allow you to build solutions on top of it. But we don't have a whole lot of time today, so I'm not going to cover too much about the partner-driven capabilities. I want to focus more on the AWS, the built-in capabilities that we have. So as I say, I'm a solution architect, so a lot of times I go and talk to customers about their business problems and issues. And a lot of times they share these type of issues, like, how can I improve my disaster recovery process? How can I improve my customer experience? Some of them are related to compliance, right? And what I do is I kind of review some of the capabilities that we have. And as you know, we release these capabilities rapidly. I mean, we've been innovating so fast, sometimes it's so overwhelming. And we really need to have some kind of framework where you can process these different types of capabilities and options and be able to meet and understand the business drivers at the same time before you can come out with a solution architecture. So usually what we do, or I do at least, is I evaluate different options and then trying to measure metrics. Measuring metrics meaning that depending on the business drivers, you want to know how you can actually measure the baseline and measure typically measure the business drivers depending on the metrics. You want to measure it after you implement something so that you can actually see the difference. And then you come up with the architecture design or solution architecture, right? So that's the typical process that we usually go through. The important part is that sometimes it's so overwhelming, sometimes you miss some of the options or capabilities that are out there. So you tend to go with something that you know how to do or something that you are very, very comfortable with. And is that the right way? Sometimes it's the right way because a lot of times by implementing something that you already know, the chances are you're actually going to do it right. But another aspect is, what if there are better ways to do it, right? So what I like to do is kind of take a look at some of the framework or come up with a way for you to process these multiple ways of implementing data replications in AWS at the same time meeting some of the business drivers. So in order to frame our discussion, I would like to focus on two different data types, database and static or storage content. And two most, I would say, common business drivers for data replications, data preservation and performance, just like Thomas Jefferson did 200 years ago. By framing the replication options this way, I believe that we can focus and discuss more relevant capabilities and related to the replication itself. So let's take a look at some of the design options that you have in AWS. As I say, we're going to focus on two different types of data. So you have a database and files and objects. A lot of times the customer will say, well, traditionally what you do is you replicate data between two servers in a data center, right? You can still do that in a single AZ in AWS. Sometimes you want to replicate data between multiple AZ in order to improve or increase your availability. Sometimes a lot of customers are now, more and more customers are replicating data between cross-region for market expansion or DR purposes. And a lot of enterprise customers are now looking to us and say, I have all these assets that I need to manage and operate. I can't get rid of them. How can I replicate some of my data from my data center into AWS? So we have a hybrid IT model where some of the capabilities or replication capabilities can be perfectly fit to address some of their needs. From a business driver's perspective, there are multiple ways to measure your business driver, especially with data preservation. So you can actually measure based on availability of data, but a lot of times the data itself is serving much higher needs, like services, applications, and systems. So sometimes people refer or measure their metrics based on availability of service or DR metrics, usually RTO and RPO. So that's where I want to kind of focusing on today. So as you know, maybe you already know this, but just in case, just to level set, typically RTO, RPO works like this. So let's say you have a last backup of your system done at 2 a.m., and some kind of event occurs, right? Let's say around 6 a.m. It could be a natural disaster, or it could be a human error. Doesn't matter. That means your RPO is going to be around 4 hours, right? If you have to go back to your last backup. So you actually lost anything that was written or changed after 2 a.m. will be lost. And then let's say it took you about 5 hours for you to recover that data. And that means your RTO is going to be 5 hours. So what you want to do is a lot of times the business will drive how much data are you allowed to lose or how fast you have to recover in order to reduce that RPO and RTO. Depending on that requirement, you will probably have to choose between physical versus logical or synchronous versus asynchronous replication. And how critical is your data? Depending on if the data cannot be lost, then you can't afford to lose any 4-hour worth of data. So there's got to be a way for you to back up more frequently. And so at the end of the day, the preservation or data preservation business requirement or metrics would drive and dictate how you want to design your replications. Another key metrics is performance. Typically, when you have a database system like this, you have a source system database with about 35 terabytes of data, and you're doing some kind of ETL process to manipulate. And it could be on a daily or weekly job that you do. Depending on how much data you have to move back and forth into the target, the total time amount it requires for you to complete the job is called performance metrics. So typically, business will say, can you do this within a certain period of time? In this case, about 10 hours. Well, this type of performance is requiring for you to optimize how fast you can read, write, and transfer some of the data over to your target. The problem occurs when underlying requirements starting to change once you design it. In this case, what if your source database goes from 35 to 70, double the size? And then the big question is, can you still replicate this in 10 hours without really breaking or changing the fundamental design? You need some way for you to scale, right, and be able to meet these changes, because changes will happen. So at the end of the day, these performance requirements will also dictate and drive what type of replication design or capabilities you will need to implement in order to meet. So these are the two major or common business drivers. So let's take a look at some of the design factors involved in replication. So typically, the replication occurs when you have two different source and target system in a distributed environment, and you process some data. And we kind of mentioned about the size of data, right? The designing a replication system for one gigabyte of data is going to be completely different than designing it for 1 petabyte of data. The size of data is definitely going to matter. So you definitely want to understand what type of data size, what size of the data you're dealing with. The second design factor is the performance of your source system. How fast can you read, write, as well as what kind of CPU memory do you have? On top of that, what type of network interface do you have in order to send this data over to your target? And then there is a change data rate, right? If it's a static, it's not moving, that means that's fine. And you can only, all you have to do is just make a copy of your existing source data, move it over to a target, and it's done deal. But if the source system is changing, especially in the database, then you're going to have to figure it out how fast this data is changing. The faster the data, more data you need to move over and be able to synchronize with the target system. So understanding the data change rate is also going to dictate that what type of design you need to come out with. And then because it's usually source and target systems are distributed, and they're usually connected through the network. So what the network between the throughput, bandwidth, and latency between source and target is going to play a key role. And I'm sharing these design factors because depending on the solutions and capabilities, whether it's AWS or third-party vendors, they're going to try to address some of these factors one way or another. And it's important for you to understand, I think the baseline is, these key factors are going to play a significant role, especially if the source system is far, far, far away from target. Your network latency is going to play a key role. Similar to source system's performance, your target system's performance is going to play a key role too. How fast can the target keep up with the changed data, right? Sometimes you may be able to keep up with the changed data initially, but later on, you may not be able to keep up. Once that happens, then you're never going to keep up the replication process. Therefore, if something goes wrong, you're probably going to lose data. So understanding how fast, what kind of resources you will need in order to meet that requirement is going to play a key role. The last design factor that I'd like to talk about is the consistency. This actually plays a significant role in designing replication. Consistency. How consistent do you want the data to be? Do you need to have an exact copy of your data from source and target all the time? Or can you afford to have eventual consistency? Can you have 1 or 2 second delay of that replication, right? Depending on the consistency requirement and factors, there's a whole bunch of design options that you can consider. So from an architecture perspective, these design factors represent challenges in data replications. Even if you made the right trade-offs and design a perfect replication system that can handle just about right data size and change rate, design will no longer work when these design factors change over time. And we all know that the requirements will change. And when they do, and especially if the data size increase or change rate increase, then you really need an infrastructure that must be able to scale and be able to adapt these changes with you. Otherwise, the entire design will go away. And that's, I think, a lot of times we resist change because we know that underlying infrastructure. And changes are OK as long as it's easy and it's going to improve our system. But changes are hard when it's really complex and it's going to cost you a lot of money and pain. And if you build the infrastructure, or if you build a system that is not allow you to adapt and change, then it's our human nature to resist that change. So at the end of the day, the replication design options, from our standpoint, you really need to understand the right tool and pick the right tool for the right job. You also need to be able to design these systems in a flexible infrastructure. Flexible means you have a lot more options, right? More options you have, more design choices you're going to have, and be able to change and adapt as your requirements change. So I'm going to introduce you 6 different common scenarios, and we're going to kind of go through these scenarios to introduce different replication options in AWS. And some of them are very typical and traditional. I think these scenarios exist in non-AWS or cloud environment, like things like data migration and HA databases and increasing throughput. But some other scenarios are very specific to cloud or AWS. So to illustrate this scenario, I would like to introduce your character, Bob. Bob is a DBA. He works for a large enterprise company, and he has over 10 years of experience. But he doesn't necessarily have a whole lot of experience with AWS. So I want to use Bob as our character and tell a story how Bob go through this journey and then face these different scenarios. So one Friday afternoon, Bob was working, and he's ready to take a nice weekend off, and Sue comes over to his office in a panic mode, say, I can't find my transaction log 002. There's no way for me to recover. There's a gap in my transaction log. How many people actually heard that story before or ran into it? Okay, a couple? Okay, few. If you're a DBA, you probably know about this. So in order to recover the database, there's a gap. That means he needs to find that transaction log. And usually, transaction log keeps track of all the changes. And if you run into a problem where you need to recover the database, you need all the transactions that happen in sequential order in order to recover that entire database. So what that means is Bob not only has to call up his backup tape company to bring the tape, and then verify whether that missing transaction log exists in that tape. And it's probably going to take about 5 to 6 hours to do so. And then he realized that current process of recovering database may not be meeting his current RTO and RPO requirement. So he's like, we need to find a better way. So he learned about AWS, and now he decided to move some of his database backup files into S3. And because he's new, first thing he's going to do is he's going to try to upload it into S3 bucket using console. So we're going to go ahead and give you another first demo. Let's say one. Of how Bob's going to upload. So he's got a backup file, a full backup file, about a little over 20 gig. And he also has some incremental backup sitting in his local drive. And he's going to go ahead and open up the console and upload it using the console, and then choose the backup file. And what he's going to do is, as soon as he starts the upload, he's going to notice that it's just going to normal speed. And if you look at the actual network trend, you will see that it's getting about 120, 40 megabits per second. It's not too bad, right? It could be better, but that's what he's getting right now, okay? So what Bob can do is, obviously, many of you know that he can probably use multi-part upload. So multi-part upload allows you to chunk that 20 gig into multiple pieces and upload them in parallel. And then once it's moved over to S3, it will reconstruct those parts into one pieces. So let's assume that that one particular file will take about 2 seconds to upload. Okay, sounds good? What Bob can do is, if he has full files, he can put it into a loop and sequentially schedule these files. So if each file takes about 2 seconds, that means he can complete the upload in 8 seconds, because he has to do it in sequential order. But Bob works for enterprise, right? He doesn't have just one database. He has many, many, many files. What if he has 120,000 files? Right? It's going to take nearly 3 days to upload based on the current process, right? So what you can do is you can think parallel. So you can actually create multiple threads that allow you to upload these files in parallel. If that is not enough, you can spin up additional machines, right? So in theory, all 120,000 files, and if you can get up to 15,000 transactions per second, that means you can actually upload all those files in 8 seconds, as long as you have these machines and bandwidth, right? So what we're going to demo, again, is how Bob is going to leverage S3 multi-part upload using the latest command line that I believe we released about a couple months ago, but it has a built-in multi-part upload. So he's going to go ahead and open up and use the copy command that comes with it, AWS S3 copy command. And he's going to upload the same exact file, the 20-some gig file, into a S3 bucket. And you will notice that it automatically parse that. So in this case, it takes about 780 parse, automatically chunk that part, a big file into multiple pieces, and it's going to upload that in parallel. As you can see, now I'm getting same exact file, same exact host. I'm getting doubling my throughput to close to 700 megabits per second. So by just simply using S3 AWS command line that allows you to do the multi-part, you can get additional throughput. Here, Bob can also use the same S3 command called sync to synchronize his current directory to S3 bucket. So in this case, Bob's going to upload or synchronize all the log file that is sitting on his directory into a particular bucket. And that way, he can basically not only back up the full backup, he can also back up all the transaction log that the database is generating. Once it's synchronized and you run the same command, all the files are synced, so it's not going to do anything. So you can basically run this command on a regular basis in order to synchronize. So at the end, whenever you're interacting, especially if you want to replicate data into AWS, think parallel. You can definitely create your own application using API and SDK, and always think about multi-part upload interacting with S3. Also, you can create multiple thread. Right? There are multiple ways to do it, and if you are a .NET, there's a parallel extension that you can leverage. Creating multiple thread will allow you to give you additional throughput, additional parallelism that you need. And then if that is not enough, spin up additional machines, right, with a multiple thread that you have. And it's going to be limited by your servers, CPU, memory, and network. But at the end of the day, you can literally get that additional throughput that you need. So we're going to introduce another scenario where now that Bob was able to move all his files into AWS, now the big question is, can he actually replicate or migrate database? Right? Static file replication is fairly straightforward. Right? It doesn't change. The file doesn't change. So all you have to do is move the file quickly as possible, and then you're done. But database replication is completely different, because you have to replicate the data that is actually changing, right? So now he's going to run into because he's also working for enterprise, he has a multiple database engine. He has a SQL Server, he has MySQL, he also has Oracle database. So he has to figure it out how he's going to migrate some of these database engine or database servers into AWS. So we're going to give you another demo that we just released, replication that you can actually do from non-RDS MySQL to RDS MySQL database. So the first thing you need to do is in order to migrate or replicate non-RDS database to MySQL, you need to create a target database sitting on RDS. In this case, we just create a brand new database, empty database in US East, and it's about 5 gigs. It's a pretty small database. You also need to figure it out or allow the source database to communicate. So you're going to have to set your security group. In this case, we have the actual IP address allowing the source database to communicate with the RDS database. And obviously, we're going to go ahead and log into the database. There are two configurations that you have to worry about. You have to actually set the MySQL database on your on-prem. First one is you have to enable the logging, because that logging will allow us to catch up with the changes once you initialize the database. The second thing you need to do is set the unique server ID. This is almost like allowing the target database to find the source later on. So if I take a look at the current master database, You'll see that the logging has been enabled, and I'm going to note that exact position of that logging, because that information that I'm going to have to use that information when I actually configure the replication. So obviously, first thing I'm going to do is I'm going to take a dump of my master database. I'm going to put it in my parts DB DMP file in my local. And then I'm going to upload or load that data dump into my MySQL database. Notice that there is a unique RDS endpoint, and it looks like the data has been loaded correctly. So I'm going to log into my target database, in this case, the RDS database. And I'm going to do a quick select on my inventory table. It looks like all the data has been loaded correctly. So that actually initialized that database. So now what I have to do is I have to set my RDS database and allow that RDS database to find the master. So remember that IP address that I set for the source. I also have the bin log information. Notice that originally when I took the backup, I have to set that position correctly. So I'm going to go ahead and make that change. Once you actually set this master, I can start the replication process. This will allow me to synchronize all the changes that is happening in the master, and it will automatically replicate into RDS. So if I go to my source database, I'm going to just to test it, go ahead and insert a record, okay, the same exact inventory table. Now, and then I'll go to my target, and that data has been replicated automatically. It's a brand new release or feature that we just announced a couple of weeks ago. And because this RDS is a managed service, you're not going to have console or server side access. So you have to kind of leverage some of the built-in functions that we offer you to configure that. So another way for you to replicate the same exact thing is if the data dump file is huge or large, then you probably want to, instead of loading it from your local server directly into RDS, you probably want to move that dump file into S3, spin up EC2 instance, and execute that data load or initializing the database into RDS. And then using the same set external master command to configure the master to RDS, and then start the replication. For SQL Server, you can use the similar technique. So SQL Server gives you the out-of-the-box log shipping capabilities. The way we synchronize the backup file and the transaction log into S3, you can synchronize those files directly into S3, and then install your SQL Server instance in EC2, and then restore that database. For Oracle, Oracle offers you the Oracle Secure Backup Cloud module that actually you can use the same rman command and then directly load that backup file into S3. It also gives you a configuration where you can actually increase the channel in order to parallelize that process. So once you have these backup files in S3, you can use the same exact rman command to restore database in this case, EC2 instance. So Bob decided to install and manage Oracle and SQL Server on EC2 instance. So there are many different ways to replicate. If you choose to use RDS, you can leverage the built-in RDS replication feature that we offer. If you choose to install and configure your database in EC2, you can continue to leverage the vendor-specific replication techniques. But a lot of times, the file that you need to move over needs to be stored in S3, and you can definitely gain additional availability and scalability. So now once you have the database, another scenario is how do you make your database highly available? Right? It's a typical questions. And obviously, Bob wants to not only move all his database into AWS, he also wants to move all his application stack along with it. So before you do that, you need to make sure that your database is highly available. So one example is for Oracle on EC2 is leveraging its built-in data guard. So built-in data guard's been there for many years. And basically, you set up your primary database in one AZ, and then secondary or the standby database on another AZ. And then what you do is you basically configure your data guard broker, and then all the redo logs will be shipped over to another AZ. Great configuration because you don't have to worry about building up another data center. You're basically leveraging the built-in multiple availability zones that we have. For RDS, all you have to do is go to the console, click on multi-AZ deployment flag, and it will automatically do physical synchronous replication for you for both MySQL and Oracle. So another scenario is the increasing throughput. A lot of times when you are running a certain type of application, things may go slow, and you need to find a way to improve your throughput. And when that happens, there are a number of techniques that you can leverage to mitigate or improve the throughput by implementing replication. So we talked about one design factors earlier, that the performance of your source system's instance matters. So by ability for you to vertically scale up your database instance will give you a significant improvement or option. So in this case, RDS SQL Server instance can be vertically improved or scale up to different instance type. You can also implement a provision IOP. And read replica is also one way for you to spread the I/O and scale horizontally. So Bob can literally go into the console, click few buttons in one weekend, and then literally implement all these changes and performance improvements over the weekend. And Bob was able to scale up his architecture. So he had a typical web application where he was taking multiple orders. He can scale up his instance to a much bigger instance. He created multiple read replica and distribute the read and write transactions. He also improved his disk I/O by adding additional provision IOPS. He can also improve performance by moving some of these large objects into edge locations. So a lot of times when we do think about performance improvement, what you want to do is you want to move the data closer to the process or data consumer, right? Whether you're moving the data closer from a disk to a CPU processor, or then moving the data into actually a client who's actually consuming. So if you have a large object, you can actually replicate or cache some of these data into multiple edge locations that we have. So Bob was able to do that, and he can improve the performance by moving some of the object into CloudFront. And then he also decides to copy or save some of the transaction in S3 bucket. From another option is leveraging different databases. So we have a relational database, and we also have a NoSQL database. So our managed NoSQL database, Amazon DynamoDB, can be a perfect candidate to move some of these hot tables that you may have. So Bob may decide to move some of the session information or session state information. They're just sitting on the relational database. And it can move these tables out of the relational database into DynamoDB. Because DynamoDB has built-in replication capability, it actually copies and replicates its table into multiple availability zone automatically. So from a customer's perspective, you'll have no idea whether it's doing it because you'll only see one table. But behind the scene, it's important to note that it has a built-in capability of replicating into multiple AZ. So by implementing these changes, Bob was able to see a huge improvement in his system, and the business is doing really, really well. So well that now Bob's company would like to open up a brand new development center. And that means Bob has to figure it out how he's going to replicate some of the resources from one region to another region, right? He has to figure out how he's going to be able to replicate all the armies and EBS snapshots. And remember, some of the informations were also stored in DynamoDB. So he's got to figure out how he's going to replicate DynamoDB tables. We also need to replicate RDS snapshots, and more importantly, some of the objects sitting on S3 bucket. So we're going to go ahead and give you another demo of how Bob's going to move and replicate these objects cross-region. So first thing we're going to show you is we released the Army copy command or feature a few months back. And using the command line, you can simply set the destination region and copy Army from one region to another. In this case, once it's copied, it's going to come back with a specific image ID unique to that region. You can use the same similar command called copy snapshot to copy the actual EBS snapshot from one region to another. And then again, it's going to return a unique image or snapshot ID that it's going to assign once that snapshot has been copied. If we take a look at the describe session, it will see that those two jobs has been submitted. And then once the progress has reached 100%, these file has been going to move automatically behind the scene. It's almost like a batch job you can kind of create and then copy these images over to another region. Another thing that we just released was the RDS snapshot copy. Just like the armies and snapshot, you can also take a snapshot of your RDS and then copy that database snapshot and then make a point-in-time recovery in another region. And similarly, you can basically set any region that you want to copy that particular RDS snapshot. And then you can set the identifier or the name of the snapshot that you want. For the DynamoDB copy, it's a little bit different. So what we just announced last week was leveraging data pipe. You can actually copy the DynamoDB table. So we're going to show you how you can actually do that. You're going to create a brand new data pipe definition. And then we're going to call it copy DynamoDB. And then when we launched this feature, we came out with a template, actually, that allows you to easily copy DynamoDB tables cross-region. So we're going to use that template. And then all you have to do is set which table that you want to copy, and from which region, and the destination table. Make sure that the table has to exist in the other side, and the region that you want. The read % and write % allocation is important because, as you know, DynamoDB, you need to actually set your provision, read and write. And sometimes you don't want to use up all your provisions by just doing the replication. So this parameter allows you to set what percentage of that provision that you want to leverage. In this case, we're just going to use up 30% of that provision. And then you can schedule it on a regular basis. So for this, we're going to use it every day. And we're gonna set the data filtering. Data filtering allows you to only copy the data that changed. So we talked about how the data change rate is very important. You definitely don't want to copy the same exact table every day, right? You only want to make identify or filter the change data and then only copy those items. So in this case, we're going to set the filter and set it to, can you actually go back? Thank you. We're going to actually set the attribute, the timestamp. And timestamp is important to keep track of the actual record that was inserted. And then we're going to filter the attribute, anything that actually created after my scheduled start time. I'm going to filter those items and then make a copy of it. Okay. So once I do that, I can hit next. And then you will see actually that the actual DynamoDB cross-region copy has been successfully saved. And also notice that there's a resource, right? we are actually spinning up EMR cluster to do this copy. So we talked about earlier that you can actually spin up additional thread and additional machine to get additional throughput you need. You can actually configure to launch additional EMR cluster with a much bigger box in order to leverage that throughput. So the way we actually release the functionality is that we're going to leverage the DynamoDB regional copy using Data Pipeline, the definition. But we're actually going to spin up the Elastic MapReduce clusters to do that actual work. So once you do that, you actually can see the actual activity schedule. And you can, once you activate it, the table is going to copy it over to destination. So the last thing that Bob has to worry about is S3 bucket, right? It's a completely different animal, right? Because it could actually hold a lot of objects, because there's no real limitation of how many objects you can put it into a particular bucket. So he has a bucket in US East, and he needs to be able to replicate that bucket in the destination, in this case, Tokyo region. So we're gonna take a look at Bob. He's an architect now. He needs to figure out how to do it. And he decided to come up with this design, right, where he's going to list all the objects in his source bucket. And then using some kind of controller, he's going to also get the list of bucket list or objects in destination and do a diff on it, right? By doing diff, he can probably get all the object that doesn't exist in his target, right? So let's say I have 10,000 objects in my source, and I only have 5,000 in my destination. If I do a diff, I will get the difference 5,000 objects that I need to copy over from destination to, the source to destination. And what you can do is you can actually put these list of objects into a queuing system, in this case, SQS, and then you can start dequeuing the items. And depending on how fast you want to make these replication, you can spin up additional machine. We talked about multiple thread and multiple machine to make these copies. So one by one, you can actually dequeue and call the S3 copy API to make that replication. Great thing about this particular architecture is that if one of the API call fails, so you have to probably do all 5,000 API calls to copy each object. If one of them fail, you can redo it. Because you still have that item sitting on your queue. All you have to do is dequeue that until the S3 copy API successfully make through that. And then you can basically delete that message out of the queuing system. Another way for you to generate the object list is using Hive. Hive comes with the EMR. You can actually set the source bucket list as one of the external table. And the same thing for the destination list. And basically do an outer join between those two tables, and then create a difference list. And that list, you can use that list to basically create queue. So the last scenario is data warehousing replication. So a lot of times, when you think about data warehousing, you don't really think about replication. But behind the scene, we do a lot of replication. I don't know how many of you actually attend the session yesterday about Redshift data warehousing. One of the speakers basically mentioned that I don't do backup and recovery on my data warehouse, because my data warehouse is actually a terabyte. There's no reason to do backup and restore, because it would take forever for me to restore my data. So what I do is I do replication. I replicate my data in multiple places. So instead of, if something goes wrong with one node, I can always go to another node and be able to provide that availability. So there's a lot of replication technologies that we actually use to create data warehousing. So Bob's company obviously is very successful. They're taking a lot of orders. They're doing, now they want to know things like impact of price changes, right? These type of analytical questions are completely different than OLTP questions, where you just want to know how many items did I sell, how many stores do I have, right? This type of analytical questions requires different type of system. So Bob thinks about this idea in one lunchtime, and he draws up this idea into his napkin. Basically, if I have this idea, if I have these data, so I have a data, inventory data, I have order data, I have a web traffic data, maybe if I integrate all these different types of data into a single database, maybe I can actually see the impact of price change, right? So a lot of times data warehousing project will require to collect and consolidate different data sources into a central location where you can run some type of BI report. So Bob wants to come up with a proof of concept, and he wants to actually build and see if we can actually answer that particular question. So he decided to pull the data from Amazon DynamoDB, and he's been collecting the web traffic information from S3 bucket. And he also has some inventory data that he can probably pull from Oracle instance on EC2 instance. And because we offer data warehousing service called Redshift, he wants to move all the data into Redshift and run some kind of BI report. The question is, what is that middle part that allows him to coordinate and move some of these data into his ultimate data warehousing system? For Bob, he wants to use data pipeline. So data pipeline allows you to kind of look at the multiple data source, or they call it data nodes, allow you to create multiple activities. The activity could be a simple shell command. It could be a Redshift copy or SQL, or some of the EMR activities that you can currently execute. In addition, you can also schedule these activities, okay, and into a central location where you can actually provide a process. So it's a really good way for Bob to create a data movement coordination between multiple data sources. You can also pull data from your remote or your data center, as long as that data source supports the JDBC connection. So we're going to give you a little demo of how Bob actually creates this in data pipeline. And I think it will be easier to understand. So as you know, Bob has all these web transaction log in his S3 bucket straight from CloudFront. So you can see that the log file contains all the IP address of who's been visiting his website. And basically, we're going to try to load this log file directly into Redshift using a brand new Redshift copy release that we just announced last week using data pipeline. So we're going to go ahead and create another data pipeline definition, similar to the way we did in DynamoDB copy. In this case, we're going to actually create a data node, and we're going to call it S3 web log. And the type, obviously, is going to be S3 data node. And we're going to schedule it on a regular schedule that we have already configured. And all you have to do is put the destination where that log file is located, and then create another data node called Redshift. So I have to create my source and my destination. My destination node is Redshift, and I'm gonna say the actual default schedule that we have and the table name where you want to load that data. In this case, we're going to call it Cloud Host. If I go to the actual table in my Redshift, you'll see that there's no data currently. We're going to actually create an activity schedule and load this data directly from S3 bucket into Redshift. So in order to do that, I need to set my credential so that my data pipeline process can log into the Redshift. I can also create activity. This activity is the one that is actually create the process to copy the data from S3 into Redshift. So in this case, I'm going to go ahead and use the Redshift copy activity. So copy function or command that Redshift allows you to move is a very optimal way to move the data or load the data into Redshift. I'm going to go ahead and put my input and output. In this case, my input is my S3. Output is my Redshift. There are 3 different insert modes. One is the overwrite existing, basically using the primary key. I'm going to update that data. I can also keep existing, meaning that I'm going to just continue to append my data. I can also wipe out my table, okay, truncate it, and then load the brand new fresh data into it. Now that I have my definition, I'm going to go ahead and schedule to yesterday so that it will run immediately, okay? And then I'm going to go ahead and activate that, save the pipeline. And looks like there's no error, which is good. And I'm going to activate it. Once I activate it, you can actually go to the console and see the job has been actually scheduled. And looks like it did. And that's a good thing. So once it actually goes in, and then it's going to go ahead and execute. We're going to come back to it. It's going to take maybe a minute or so to load that. So while we are waiting, I'm going to show you the other pipeline activity. So the Bob had to also copy his inventory database, right, sitting on his Oracle database on EC2. So in this case, I'm just using the SQL data node type. And because it's going to use the JDBC to connect into Oracle database to pull the data, I put my connection string. In this case, I'm going to actually, instead of loading the data directly into Redshift, I'm going to load the data into my staging area in another S3 bucket, where I can do some additional data cleansing or conversion. And then using similar copy command, Redshift copy command, I'm going to load that inventory data directly into Redshift. Okay. For DynamoDB, we also offers the direct copy command from Redshift. So you can actually set your source data node to DynamoDB node and the specific table where you want to extract the data. And you can also set the destination, which is the Redshift database. You can also, once you have all that definition created, you can actually export this definition in JSON format and then have some kind of version control. Or you can use the exact same JSON format to run on your command line tool. So we're going to go back and take a look at the S3 command, and looks like it finished, just perfect timing. So we're going to go ahead and run the same exact SQL statement and see that if the data has been loaded. It looks like all the data has been loaded, okay? And another great thing about data pipeline is it can also do a schedule and fail activity. So if something goes wrong, you can also spin up additional activity, and you can kind of coordinate that. Another interesting solution is using third-party tools. So like a company like Attunity has this product that allows you to move some of the database directly into Redshift. Great thing about this type of solution is that instead of just doing an initial load, it can also capture changes. So as the database, or Oracle, in this case, Oracle database changes data, it can actually capture this data and then load that change directly into Redshift. You can see that they also leverage S3 as a staging area because it's the most optimal way for you to interact with AWS resources. So you actually use the S3 to pump the data initially into S3, and then using the Redshift copy to load the data. Once that happens, it will do an incremental change data updates using SQL command. So Bob was able to aggregate different types of source data into one. Now he can actually see the data from the CloudFront, the unique visitor, as well as can combine the revenue and inventory. And now all of a sudden he can actually see when he make changes to the price, what will happen or what has been happened with these different types of data. Allows him to actually see the insight of the business itself. So from an architecture perspective, this type of a data movement can really be coordinated through data pipeline. And he can also move some of these data to another region using the standard built-in API calls that we provide. And obviously, Bob has been promoted. Now he's not a DBA. He's actually an architect. So for some key takeaway, remember the design factors that we talked about? And it's a really fundamental way of evaluating and looking at the design itself and make the right trade-offs. Sometimes it's not possible, but sometimes you have to make the trade-off to get the right system design. Think parallel, right? Whenever you are replicating data from outside to inside, think parallel. There are multiple ways to load the data, whether it's a built-in API or using our SDK or third-party tools to move the data. There are different ways to do it. You want to maximize the throughput as possible, and so you can have a much better performance. And pick the right tool for the right job. There are multiple options for you to leverage. There are multiple ways to replicate. We give you a flexible platform where you can actually pick and choose. It doesn't have to be AWS. There are a number of third-party vendors offering different types of replication options. And that's the great thing about building your replication system on top of AWS infrastructure. So I'm actually running out of time. If you have any questions, I'd be happy to answer any questions. I'll be standing here. So thank you very much for coming. Appreciate it.